So you know the binary search work in sorted array. So for this case, what you need to do is find the pivot, and then once you found the pivot, you do a search from left to right. So for this example, you have something like this. So the pivot is this. So basically search from 256 and then you search from 012. Like a break it down to multiple steps. Yeah, first find the pivot, then binary search from here, the left, binary search from the right. So the pivot is basically the first number that is greater than the next number. So that should be very straightforward. Like for okay, like create a pivot here. 0. Start with 0. Int I is less than 0. I is less than that length, or n minus 1. N minus 1. I plus plus. If basically if nums I is greater than nums I plus 1, you set the pivot to okay, I plus 1, then you break it out, the loop, and then you do a 2 binary search here, which is var A, var B. Then you put an offset. So you can do a offset in Java, which is 0 to pivot, then inclusive, exclusive, where n is nums that length. Then you don't need the sort, and this will give us n solution log n, right? So a less than b and b is less than 0. Both of them are false. Output is false. Okay, so the problem here is a parameter. Target should be the last. Sorry. So API call, misleading API call. Okay, works, but it's low because of the sprint. Good, it's 1 millisecond. Can we make it 0 millisecond? Try to further optimize this using a divide and conquer approach. We're trying to find the pivot. If there's no duplicate, it's quite easy. But if there's duplicate, that's where the hard part comes in, because it's possible that you have something like this: 1 1 1 1. You have 2, right? How do you know we're gonna go searching left and right? So eventually you'll be forced to go through everything. But that's a worst case scenario when you have a lot of duplicates and then you only have like very few, like something like this, and just like most of the items are duplicate. Now we can start further optimize that using divide and conquer approach, where we'll try to search the pivot, assuming that they're all unique. That's quite easy. The problem is the duplicate, right? So I'll put the low and I'll create a customized version of searching. But so if the low is okay, so we calculate the mid. Mid is equal to low plus high minus low divided by 2, right? So if your nums mid is greater than nums mid plus 1, then you know that this is the pivot, right? So we just return the pivot, which is return mid plus 1. Got it. Okay, so what's the other condition? The other condition is else if, now there's a duplicate. If this is same as the mid and it's also the same as the last, so you don't know where you're going, you're gonna go either left or right. So that's one of the conditions where nums mid equal to nums high, low is equal to high, and nums low is equal to mid. Low is equal to nums mid. This is where you have to go to both left and right. So what if is It's only one way. Like nums low is greater than the mid. So if you have something like this one is less than the mid, 2 is less than 0, so you basically move the pivot here, right? You basically know that this is increasing, so it's on the left. So that part is, if it's less than the mid, you know that it's increasing. The low, mid, high is equal to mid minus 1, else low is equal to mid plus 1. Or you can actually reverse that. Put it here. So we do a recursive call from this, trying to figure out where it's gonna nums target low is here until high. Okay, then you go to the left, which is mid minus 1, then this is low. Okay, that's the case here. And what's your exit condition? If low is less than high or greater than high, then you return -1. It's in the pivot, you can't find it. Else you have to you do both of it. So you have to search for this one. You can go on the left side first, which is this. Int a is equal to this. Return a is equal to 0. Okay, let's just make this to be return 0, pivot 0. So 0. Like that. So instead of using this one, we could do something like div c the nums target, then high low, low high, high, where low is 0, low is 0, and high is n minus 2. Okay, you're wondering why it's n minus 2. Because we're doing a plus 1 here, right? So you don't want to be exceeding that check, so it should always be less than n. Let's try to run this. Okay, submit. Load. This should be okay. Should be like this. Yeah, try it out. Okay, we just remove this print, see if it's actually, this is not really that optimal, because you do a divide and conquer here, which is on the worst case you still have to scan everything. But just to show off, like, yeah, we could do a divide and conquer. Yeah, it's 0 ms. So basically, if it's like this scenario, you don't really know if you're gonna go left and right. So basically what we're gonna do is go everything from the left also. So if it's the case like this, where 2 is greater than the middle, low is greater than the middle, then you know that you have to scan from this side, right? So this low is greater than middle, so you just have to scan from the left. So yeah, I think this is the solution for this. If you like this video, please feel free to hit like and subscribe. I'm gonna solve more daily LeetCode problem. Thank you for watching, and hope to see you again in the next episode.